Hey guys, welcome to a masterclass session on machine learning with tree-based models in Python. Uh, so before we begin, please do let me know if you can see my screen and if you can hear my voice. Okay, great. The topic for today's discussion is machine learning with tree-based models. So why tree-based models? So people who come from computer science background or maybe mathematics background will be well versed with something called graph theory, right? So in graph theory, what happens is there are nodes, also called vertices, and there are edges between them, right? So in case of tree-based models, what happens is when we are trying to find out something, to predict something, in machine learning, typically we are always trying to predict something, right? So in that case, what happens is we are taking a decision at a node and then moving on to other nodes based on the decision made. Okay, so that decision is made at a node and it moves down to other child nodes, hence forming a tree-based structure. So before moving on to the tree-based parts, I'll give you a brief introduction of what machine learning is, what are the different paradigms of machine learning, and what entails with it, and what are the different types of algorithms that we normally see around each paradigm. So the agenda for the day would be first to know what machine learning is, an overview of that. Then the different types of machine learning algorithms or the paradigms of machine learning, and typically what sort of algorithms we see across the different paradigms of machine learning. Introduction to the 𝐸𝐻 algorithm, which is basically classification and regression trees. Then we'll do a quick introduction of what decision trees are actually, the base of the tree-based models in machine learning. And then we'll be talking about how to split a particular node in a decision tree and how can it decide that based on what parameters or what indices do I make that decision. So once we are through with that, we'll go into something called ensemble methods for machine learning, where we use multiple learners, as we call it. So we'll talk about random forest, what is bagging, what is boosting, and then a bit we'll talk about um, gradient boosting and extreme gradient boosting. Okay, so first, what is machine learning? So machine learning is a type of artificial intelligence that provides computers with the ability to learn without being explicitly programmed. Machine learning focuses on the development of computer programs that can change when exposed to new data. Okay, so what does this mean? It means that when we're trying to write a program for printing, say, natural numbers from 1 to 100, okay, and we can do that easily using program, right? So if someone asks you to print all the even numbers between 1 to 1000, you have to set a counter and you have to increment it by 2, and we start with 2 and then keep printing, right? So that is how we print even numbers from 1 to 1000. But the computer is just understanding what you are instructing, right? It's not learning anything. It is not being given any data. So what about I talk about something where uh, there is not explicitly something which is not explicitly programmed, which I'm making the computer learn to do, just like a child, right? When a child is born, the child does not know how the world works. The child does not have world knowledge. So what it sees around from the child's parents or relatives, elders, right? So the child learns slowly how people talk, how people walk, different things about world knowledge. For example, the child will know that if I put my finger in the fire, I'll get a burning sensation, right? So that might come as an experience, which is called learning, and it might also come as a sort of already adopted knowledge, which is passed on from the parents, right? So when we are trying to teach the computer to do such things, where we are giving it a data set and it is trying to learn something based on that data set. That is called machine learning, where the machine is actually learning something, right? So people keep talking about deep learning and machine learning. So artificial intelligence is not only machine learning and deep learning, right? There are other parts of artificial intelligence also. Machine learning is a method of solving artificial intelligence problems. For example, we have three major methods of solving artificial intelligence problems. First is called rule based. For example, when we are trying to build, say, a grammar for a particular language, we'll need the rules for that language. Those rules might be different, say for Hindi, and yeah, correct. Rule based is one of the methods of solving artificial intelligence, right? So what I'm trying to say is, say for a particular language, I'm trying to build a grammar, okay, to understand the grammar. So if you have seen an application called Grammarly, it is based on understanding what you're writing is correct or not. So that is what that tool is all about, right? So how does it do it? It cannot learn the entire stuff, right? Some rules have to be put into it. So machine learning started around 1980s in a proper way. Before that, here and there were some statistical methods which used probabilistic modeling. But from the 80s, the paradigm of machine learning started. Before that, mostly it was rule based. So even now, there are certain tools that are built based on rules. Okay. So what machine learning does is it learns the rules automatically. But if the rules are if the number of rules are very small for a particular problem, we don't need to train the computer to learn the rules, right? It is given the rules and it can operate based on that, right? So that is one way of solving artificial intelligence problem. The other way is the statistical method, where it has a data set and from that it infers the rules, okay? So machine learning is the first way of doing it, and deep learning basically is a part of machine learning where we used uh, deep and dense neural networks to solve problems, and it requires huge amount of data. So in short, that is what AI, machine learning, deep learning, and rule based models are all. Okay, so there are these are the three different paradigms of machine learning. First is called supervised learning, then reinforcement learning, and unsupervised learning. So supervised learning is when I'm teaching someone to do it, right? For example, as I said, that the knowledge can be adopted from something. So if the parent is telling the child that, okay, if you put your hand in the fire, it will burn, that is called supervised machine learning, okay? And it is based on some teacher signal or a guiding signal, right? So an example of supervised learning would be understanding the sentiment of a particular review, or understanding if a picture contains a cat or a dog. That is called supervised learning. So how do we solve this problem? We give the machine a data set, and there is an algorithm that learns from that data set, right? That is called a supervised learning algorithm. So when it is given, say, around 10,000 movie reviews, and all those reviews are annotated with either a positive annotation or a negative annotation, right? That is done manually by say people who are annotating. They are called annotators, right? So what the machine does is, using the algorithm, say a supervised machine learning algorithm like decision tree, which we will learn today, right? So it looks at the data set and tries to understand if given a new sample, new movie review, it will try to predict if the sentiment in that movie review is positive or negative, okay? And again, for given an image, it can either contain a cat or a dog. So it is again given a 10,000 or say 20,000 images, all of them labeled with either cat or a dog label. So the algorithm will automatically learn what features are there in those images that differentiate between a cat and a dog. This is done automatically, right? That is called supervised learning. Okay, so for reinforcement learning, as I said, so the child puts its hand in the fire and learns that, okay, if I put my hand in the fire, I'll burn my hand. Okay, there is a burning sensation that is not great. That is called reinforcement learning. The way you train dogs, right? If it does something correct, you give it a reward. If it does something wrong, you say give it a time off. That is called reinforcement based learning. Unsupervised learning is where you don't give any guiding signal, and based on the inherent intrinsic properties of the data, the machine automatically learns. Okay, so for example, if I want to categorize people based on, say, what sort of movie they might like. Okay, so maybe older people would like old movies, and like younger people would like newer movies. That based on that assumption, i will I will form buckets of people with respect to ages, right? And then based on that, I'll try to learn what sort of movies they like or don't like. So that is called unsupervised learning, where we do something called clustering. In supervised learning, what we do is called classification. Okay, reinforcement learning is like teaching a robot how to walk on a path. If it goes the wrong way, we tell it, okay, this is wrong, so don't go that way. So next time it will not do that. That is called reinforcement learning. Okay. Okay, so moving on, let us look at the framework for machine learning algorithms, which I've mostly covered. So supervised is basically where we are giving the algorithm a signal, teacher signal, or a guidance to learn something. For example, the one with images annotated with either a cat or a dog, that is called supervised. So supervised learning has two parts. One is called classification, where we are trying to identify a particular class. In this case, dog is a class, cat is a class. For in case of the sentiment case, which I said, positive is a class and negative is a class. Okay, and what are the different types of algorithms that we use for classification purpose? We use k nearest neighbor trees, decision trees, logistic regression based classification, naive based support vector machines. Okay, so we'll be looking at decision trees today. For regression, again, we use decision tree and random forest. So what is regression? In case of classification, we have a predefined set of values. For example, the movie review should either be positive or negative. Okay, we can't say that it was partially positive and partially negative. Okay, so we have to tell one of the classes. So the categories are fixed, pre-decided. In case of regression, it's a prediction of a continuous value. For example, if I'm trying to predict house rent in a particular area, so based on what sort of people live there, okay, based on the income of people living there, or based on certain other features, I can decide what should be the average house rent of a particular region. So that's a value, right? That is not a predetermined case. It's not a predetermined category. So that is called regression. Okay, regression can be either linear or polynomial based on the problem. And decision trees, logistic regression, random forest are used for both regression and classification purposes. Unsupervised paradigm, as I talked about, clustering, when we are putting data points into buckets based on their features. Like as I mentioned, the problem of when people, what sort of movie people will like. So based on their age groups, I'll be clustering people. Okay, so I can use other features also. Then we have association analysis. Association analysis uses algorithms like a priori or FP growth, where we are trying to find association between items in a data set. For example, if I have a supermarket and I want to place items so that it is my sale goes up and it is easier for people to access things, right? So I'll use an association analysis algorithm. Like how I'll see association between bread, butter, and jam. So I know if people buy bread, they should have easier access to butter and jam, right? So that will be sort of on their shopping list. So whenever I'm making a shopping list, whenever I write bread, I'll be writing butter and jam after that, right? So keeping these things together would obviously impact the sales. So that is how association analysis works, and I don't need to have any teacher signal for that. I don't need to have any annotation for that. based on the patterns in which the users buy products, I can actually associate products with each other. Okay, so Surendrax, is there any hands-on this topic? So Surendra, the problem is we don't have enough time for the hands-on, right? It's a 1 hour session. We'll be covering an overview of decision trees today and an overview of machine learning in general. Okay, so the third is the reinforcement learning part, which I talked about, where we are teaching a machine to learn along the way. So when it is doing something incorrect, we are giving it a punishment, and if it is doing something correct, uh, we are trying to sort of give it a reward. Okay, so reward and punishment based thing. So typical algorithms for clustering are k-means. There are other algorithms like hierarchical clustering, db-scan, svd, principal component analysis. Then there are several other. Okay, so classification algorithms, as I said, we are trying to classify a record. So is it cold, yes or no, predefined labels, right? Will you go to work today, yes, no, or maybe? Three classes. So for example, in case of uh, identifying the sentiment of a particular text, say a movie review, I can have positive, negative, and neutral, right? Someone who has said that the movie is okay. Okay, it's not very good, it's not very bad, it's okay. So it's a sort of neutral. So there, so we have three classes in that case, right? If there are two classes, it's called a binary classification problem or a two-class classification problem. If there are multiple classes, as in this case, it's called a multi-class classification problem. So these are predetermined set of categories that we have to put the data into. The buckets are fixed, and we have, whenever a new data set comes, new data point comes, new sample comes, based on the features of that uh, new sample, we have to put it in one of the buckets. Say in this case, it will be either yes or no. So what will I teach the machine how to understand if it's cold or not? Based on the temperature, right? So if the temperature is low, it is cold. If it's high, it's not. So based on that particular feature, it will decide. Okay, so that is how we use decision trees. Okay, so we'll come to that in a bit. So regression is predicting numerical values. Okay, so for example, what will be the temperature tomorrow, or say on the 5th of April 2021? So how do people predict temperatures? If you look on Google weather, you'll see that there are predicted temperatures for different days, predicted weather for different days. So how do they do that? Based on the previous data set. So it's a supervised algorithm again. So regression means we are predicting a value. So how are they doing that? Based on the data of the previous years. So for April 5th 2021, I'll see the data for the last 10 years. Okay, and there are other certain recent conditions that we have. So based on that, we'll sort of try to predict. So the nearer the date, the better the prediction becomes, because the recent data set of the weather would be available. So again, if I am trying to see how much discount you can give on a particular item. Okay, so say I'm trying to predict, say during the big billion day sale, how much discount I can give for a particular item. So that is again a regression problem. Okay, I'm trying to predict that before that day comes. So that is how these companies like Flipkart and Amazon work. So how much discount should I give that people will buy this product more, and how much is an admissible discount, obviously. So classification versus regression. Classification predicts a categorical outcome. Is it either cold or hot? In case of regression, we are predicting a continuous value or a continuous outcome. What is the temperature going to be tomorrow? If I'm asking if it is going to be cold or hot tomorrow, it's a classification problem. If I'm asking the temperature for tomorrow, it would be a regression problem. So coming back to the CART algorithm. So CART algorithm is basically uh, short for classification and regression trees. So as I said, decision trees are used both for classification and regression. So this is a typical scenario where I've taken a data set and I divided it into a training data set and a testing data set. Okay, so CART algorithm provides the foundation for decision trees, random forest, and boosted decision trees. So let's move into the algorithm. So suppose I've given a data set. I'm given a data set that if the color is green and the diameter is 3, it should be a mango. If the color is yellow, again the diameter is 3, it should be a lemon. If the color is red and the diameter is 1, it should be a grape. So if you see line number 3 and 5, they are similar. Right. So which basically means that the same data set has come again. It's not a repetition. When we are trying to get a data set, the same data can get repeated. That's okay. In that case, that for those particular cases, the prediction becomes even better. Again, sometimes if it's yellow and the diameter is 3, it can be a mango as well. So the entire data set is passed on to a root node. As I said, we'll be talking about nodes now, and we'll be taking a decision at a node and then moving forward into child node. Okay. So how do we take a decision? We have to get a condition. So on what do we take a decision? On what feature do we take a decision precisely? So when I'm given a data set, it can contain several features. In this case, I have two features. So I'm trying to, based on the color and diameter of a fruit, I'm trying to predict what fruit it is. So for a human being, it is very easy because we have associative memory, right? We know that when I'm seeing the shape of the fruit, the visual of the fruit, I know I have seen it before. I know it's a mango, right? But the machine does not. So it has to learn based on features. We also learn based on features. But the way that human beings learn is more like associative memory or episodic memory. So in deep learning, these things are getting modeled nowadays over the last 4 or 5 years. But previously, when we have to start with AI, we have to go through the different ways of learning these, and all these things that I was talking about, like associative memory and episodic memory. These are just mostly in theory level. Eh, The models that are sort of trying to implement this are not that good yet. Okay, so anyway, so what I'm trying to say is based on the color and dimension of a fruit, I'm trying to predict what fruit it is. So first, which of these two features should I take so that my split becomes better? So I can split more number of fruits into separate categories. Okay, so if I see red is only for grape, right? So if I split at red, is color is equal to red. So I get, if the color is red, then it is definitely a grape according to this data set. Okay. If it is not red, it can either be a mango or a lemon, right? So these are the three data points, 1, 2, and 4, which go in the false direction, right? So this is the critical part. What feature should I take to, and what value of that feature should I take to make the decision? That is what we'll be learning today. Okay, so how, that is how decision trees work. Okay, so this is a classification case. In regression case also, it follows the same method. Okay. Okay, so now you can see these subsets become the input to the two child nodes added to the tree. So this is the data set that comes into the root. And now when I've split it, is the color red? Yes, the color is red, it's true. Then these are the two data points, right? 3 and 5, which move into this particular node. At this node, I have nothing to decide. I already know it's a gray, right? So this node, which has only one label, is called a pure node, which means I don't have to split it further. Okay, but at this node, I still have to decide. So what is my problem? My problem is based on the color and dimension. I have to finally decide what fruit it is. Okay, so I'll take different decisions and finally arrive at a conclusion. So if the color is red, I know it's a grape. I don't have to take any more decisions. So this is called a pure node. Over here, I have more than one labels. This is called an impure node. In the next few minutes, we'll be learning how to measure how much impure a node is. And Based on that, we'll be taking a decision. The more impure a node is, the less it has a chance of splitting, or we'll not be using that node, we'll be not using that feature per se to split that node. For example, if we had used dimension here, if we had used dimension here, that dimension is 1, again we would have got grapes here, and the same data, it would have been split in the same data set, right? The dimension 1 is only for grapes. So which feature to use so that the impurity of the resulting child nodes is minimum? That is the decision that we'll be taking. That is the method of how decision trees split into child nodes, which we'll be learning today. Okay, so what is the goal? Given a basket of fruits, based on the color and dimension of the fruits, I'll be separating them into different bowls, and each bowl will contain a separate fruit. Okay, that is the goal of the decision tree, right? So this is the basic methodology followed for trees, right? For tree-based algorithms. So I have a basket of fruit. I check if it is red or not. Okay, or say I check if it is not red. If it is not red, then it goes here, and if it is red, it goes here. So this becomes a separate category, pure node completely. Okay, so the goal is to unmix the labels moving down the tree. In other words, we produce the purest possible distribution of labels at each node. So whichever feature I might, in this case we have two features, right? We have two features. We might have up to around 1,000 features for a particular data set. So which feature do I start with so that the resulting nodes are the purest compared to the other features? So that is the decision that we are going to take, so that the level of unmixing of the labels is maximum. So what is the trick? The trick to build an efficient decision tree is to understand which question to ask, basically which feature to select, right? And to do it, one needs to quantify how much a question helps to unmix the label. So in this case, first I ask if the color is red. If it's true, I already know it is perfectly unmixed, which means it is a pure node. Here I again ask if it is green. So if it is green, it will be definitely a mango, but if it is yellow, it can either be a mango or a lemon. Okay. Again, this node will be pure, this node will be impure. We cannot ask any questions on dimension because all of them are same. We have to pick this particular feature here, which is obvious from common sense. If we use our metrics for impurity also, we'll see that it will take, we have to tell that we have to split based on the color of the fruit. Okay, that feature we have to select. So the first metric that we will talk about is called the Gini impurity. Okay. So at this node, the Gini impurity will be 0. So how do we calculate the Gini impurity for a node? It is 1 minus the sum of the square of the probabilities of each node. Okay. So what does PI mean? Let us look at this node. There are two data points here, right? Both are for grape. So what is the probability of the first one? 1 by 1, right? Or say 1 by 2, and again 1 by 2, right? So in that case, what will happen? We'll do 1 minus, so it's the sum of the probabilities of each of the cases here that we have. What is the probability of a grape here? It is half or 1. The probability of grape is 1 here, right? So both of the cases, it's a grape. There is no other case here. So there are three cases, 2 are mango, 1 is lemon. So it's 1 minus 2 by 3 whole square minus 1 by 3 whole square. How much does that come to? 1 by 3 is for lemon. So what are we trying to, you guys are not getting the point here. What we are trying to see is the labels here. How many labels are there? We are trying to find pure nodes based on the labels. If one node contains only one label, one type of fruit, only one fruit, that is grape here. So don't think about these features. Think about the label that we're trying to predict. So what is the goal of the problem? We want to predict what fruit it is, right? So we have to find pure nodes. So why we are trying to find pure nodes? So that we take such decisions, so that when we take those decisions, we can land up on a node where all the cases are same. So we can tell with surety that, okay, this is a grape. So in this case, if I see the color is red, okay, I know it's grape. Next thing, if it is not red, I'll see if the color is green. If it is green, I'll tell for surety it's a mango. If the color is yellow, then I can't say. It either can be a mango or a lemon, because after this we can't split it anymore. Both the values are same. So till here we can say it's a pure node. So over here, when we are calculating the Gini impurity, what we'll do is it's 1 minus 2 by 3 whole square minus 1 by 3 whole square. Let me try to put it down. 1 minus 2 by 3 whole square. This is for the mango part. Okay. And next minus 1. I'm really bad with this, guys. So just try to bear with me. Whole square. So what did this come to? 1 minus 5 by 9. Correct. This part is fine. This is equal to 4 by 9, which is equal to 0.4. Great. So this is how we sort of find the Gini impurity. So this is 0 and this is 0.44. So how do we find the impurity of a split? This is just the Gini impurity of the nodes. So what we need to find out is the Gini impurity of a particular split. So what we do is we find the Gini impurity of each of the nodes, we sum them up, and we subtract that from the original Gini impurity of this node. If the Gini impurity is positive, then it's impure. So the one with the least split impurity, the Gini impurity of the split will be selected. Okay, I don't think you got that part, but that is sort of an advanced thing. You need to understand only here what Gini impurity. So why is Gini impurity or Gini index used? To select the best question to ask at each point, or the best feature to select at each point, and which value of the feature to select, right? Using these questions, the decision tree is built recursively on each of the new nodes. There's no further question to ask. So here we don't have any more questions to ask. All the questions are exhausted because we can't split this anymore. Here what we'll be getting is yellow, yellow, 3, 3, mango, and lemon. We can't split this any further because these are all same, right? So over here we are getting a pure node. Here this is pure and this is pure. So if these are the two questions that we are asking, this one and this one, then we can land up on pure nodes. But if this is the path that the new sample takes, the color is neither red nor green. If it is yellow, then it's very difficult to answer that question. Okay, for this particular data set, we have shown only 5 data points, right? There can be more which will be able to through which we'll be able to again break this node. Okay, so moving on. So this is what happens, right? First we ask if it's red. If it's red, we know for 100% if it's gray. If it is not red, then this is what we are left with. Gini impurity is 0.44 for this. What do we split here? We test if the color is green. If the color is green, then we have 100% mango, which means it's definitely a mango. If it's not red, but the color is green, so when we get the new sample, it's say it's a mango, it's a green mango. So we come here, we see, is the color red? No, false. Now we ask, is the color green? Yes, so it's a mango. So we have classified that example into a mango. Now say we come here, the color is yellow. We come here. Is the color red? No. Is the color green? No. Then it has a 50% chance of being a mango or 50% chance of being a lemon, but not a grape. So we have reduced the probability of some of the classes. We have come down to two classes only. It can either be a mango or a lemon. That is the distribution that we have at this node. So I'll quickly run over what decision trees are. We actually covered most of it. So in a similar way, let us take a real life example to understand what a decision tree is. It is a graphical representation of all possible solutions to a decision based on certain conditions, just the one that we saw. Suppose I want to take a job which offers me a minimum salary of 50,000. I have commute time of less than 1 hour and I'll get free coffee. So these are my conditions based on which I want to take a job. Okay, so let me look at the different job offers that I have. First job offer comes in. Is the salary at least $50,000? No, reject. Second job offer, is the salary at least $50,000? Maybe it's 55,000. Okay, yes. The commute is less than 1 hour. The commute is 2.5 hours. Reject. Third one, is the salary greater than 50,000? Yes, it's $50,000. Okay. Commute less than 1 hour. Commute more than 1 hour. No, it's not more than 1 hour. It's 45 minutes of travel. Okay, so no, the commute is not more than 1 hour. Does it offer free coffee? Unfortunately, it does not. Decline the offer. Fourth job offer. Is the salary at least 50,000? Yes, it is. Say it's 58,000. Is the commute more than 1 hour? No, it's half an hour. Does it offer free coffee? Yes, it does. Accept the offer. So this is like a decision tree, and these are the nodes, and we have already seen such cases, right? So this is a real life example of how human beings take a decision, and based on that exact model of decision theory, we have designed something called a tree based model, which is a decision tree, and which is based again on the CART algorithm. So how does a decision tree algorithm decide where to split? We already know this question, right? We have learned it ahead of time. So Gini index, through Gini index, the measure of impurity used is in building decision tree in CART. But Gini index is not the only way of deciding it. We have other methods also. One is called reduction in variance. Okay. So specifically in case of regression problems, we see nodes where the variance splits for which the variance of the entire data gets reduced, which means the span of the data is less, it's less scattered. We'll sort of choose those nodes with those features. Okay, this is specifically in case of regression problems. Entropy and information gain are the same thing. Basically, information gain is formulated by entropy. Information gain, the less entropy is there in a system, the more is the information gain. So what we're trying to calculate is, at a node, are we gaining some information? So at a root node, I have the information, say I. Okay. So how information gain works is, say I have a root node and I can split into two nodes, this one and this one. So now this is my root node. The information gain here, suppose, is say Ig, or say I can put it IRC. It's a root node information. So this is child 1, so it's I1, and this is I2, information gain of I2. So what I'll do is I'll add the information gain of both of these. So what I'll test here is I1 plus I2 greater than or equal to the information gain at the root. If it is not, then there's no point in splitting if I'm not gaining any information. Okay, so that is how information gain works. And how do I calculate I1 and I2? It is again based on the probabilities. Okay, it is the minus of log of the PIs. That is how we formulate the entropy. So I1 is basically 1 minus sum over the log of PIs. Okay, in the previous case it was 1 minus for Gini index. For Gini index, we saw it was 1 minus sum over square of the PIs. In case of entropy, it is 1 minus sum over log of PI. So this is how I calculate the I1 and I2. So entropy is this part basically. This is entropy, and 1 minus that is the information gain. So this entire thing which we have here would be the information gain. Thanks a lot, guys. That's all from my side.